Black holes are one of the many mysteries of the universe. Now, there's a specific type of supermassive black hole that lies at the center of galaxies, that shoots out jets of radiation across the universe. And today, I'm going to be taking you through the process of how I analyzed one. My name is Jordan Foreman, and this is my project on how I did a gamma ray analysis of the active galactic nucleus 1ES1215 plus 303. An active galactic nucleus is a supermassive black hole that's lying at the center of a galaxy. And what makes the supermassive black hole active is the fact that it is actively consuming and accreting matter. And as it consumes and pulls in that matter, it begins to form an accretion disk. And in this process, the black hole can actually produce a jet of plasma and radiation that shoots out from the core. And this emission can be seen across all wavelengths, so from radio all the way to gamma rays. The particular source that we are looking at in this analysis is actually a blazar, which is a subcategory of AGN. What makes an AGN considered a blazar is that the jet emission is pointing directly towards our line of sight. We have a head-on view of that emission. I analyzed 6 months of gamma ray data from the Fermi Large Area Telescope, which is also known as the Fermi Gamma Ray Space Telescope. This is a space-based telescope that surveys the sky every 3 hours. Now, for this analysis, I analyzed 6 months of data spanning from January 1st to July 1st of 2021 using the Fermi tools, which are specifically designed to work with Fermi data. I set the energy range to be from 100 mega electron volts to 500 giga electron volts. I used the LAT 10-year source catalog to include any other sources in the field of view, and the method of maximum likelihood estimation to estimate the emission of 1215. All other specifications for this analysis were chosen based on recommendations made by the Fermi Science Support Center for AGN analysis. And for the analysis, I created numerous plots to interpret the results. So here we have the high energy photon emission probabilities. And the top plot shows the high energy photon emission probabilities for all of the photons within our energy range in this field of view. So the pink diamond there represents our source, 1ES1215 plus 303, and actually the green diamond on the right is another AGN that is very, very close. It's less than a degree away from 1ES1215, so we plotted it there just because of its proximity to our source. You can see here that with the warmer colors, those represent photons that have the highest probability of having been emitted from 1ES1215. And the cooler colors represent photons that have the lowest probability of having been emitted from our source of interest. And here we can see that there's a concentration of photons around 1ES1215 that have a high probability of having been emitted from it. And then there's also a large collection of photons that have obviously not been emitted from our source. Now for this bottom plot here, I adjusted the energy threshold to only show photons with energies greater than 10 GeVs. So as we can see here, the concentration of photons is significantly reduced, and there's only a handful of photons that we can see that have a high probability of having been emitted from our source. Now, next I plotted the light curve. So this top panel shows the light curve that we created for the 2021 analysis. So this is the light curve for the full 6 months of data. It's 10-day binning, which means that there are data points taken for every 10 days over those 6 months, which amounted to about 18 bins. That top panel is just the 6-month data. Now here we added the current data to the end of the long-term gamma ray light curve. We can see that when we compare the flux of the 2021 data to that of the rest of the long-term light curve, it's obvious that the flux is significantly lower than a lot of those flaring states that it was showing previously. Lastly, I plotted the spectral energy distribution for this current analysis. I overlaid this with the SEDs for the previously observed low state and high state for the source. The current data is in black, and the flare that was observed in 2017 is in pink. So we can see that that energy distribution is a lot higher. But when we look at the low state that was observed from 2008 to 2011, this current 2021 data matches it almost exactly. It's very, very similar. Now, from these results, we've actually concluded that 1ES1215 has actually reached a low state after flaring for about 6 years. And we can see that with the results from the light curve and the SED. They are both consistent with what has been observed when it was in its lowest observed state back in 2008 to 2011. Thank you so much for watching. My name is Jordan Foreman. It's been a pleasure.